Hello everyone, welcome to ar.arena channel. Today it will be about Grasshopper and Rhino. We will try to make like the diamond pattern shape. We take the concept from one of the tunnel al Nusail city in Doha. So we will try to make this panel diamond shape on the surface using Grasshopper. So let's start. From Rhino I will start a new object with meter. Let's open Grasshopper. Let's smallest a little bit to see what we will do in our Rhino. So I will start with construct point. I will start with my 0 and let's make curves to make our surface. Second point, it will be on 50 meter. And in X way, I can make it as a 15. So I have now 3 points. In this case, I will try to make my curve. In this point, we prefer to not to use arc 3 point, because in case of using the arc 3 point, later on when we make our surface, it will cut the surface to the 2 B-rib, and we don't want that. We want one line with one surface without any segments on the middle. So instead of this one, we will choose interpolate surface, and then I will merge my points to create my curve. This will be my curve 1 or arc 1. Take 2 copies. And then I will change my X position in this way. So let's say I will make it like 70. Or make it on Y. And I will multiply this distance . So I have now my 3 curves. This one I will make it like more bigger, so we can, in this distance, increase it to 60 Now this is the last one, need in the middle, so in the middle I will choose from this one to make it 60. And in this first point I can make this by -10. Let's go to the font. So now this is not in the X way, it's needed in the Z way. It will be here. So now in this case it will be, this is the point of the size. Maybe also I can increase it, let's make it more than 300 and can increase the size. This one, it will be my second arc. And this my last. Now I will start to make my loft. So we will merge the data here for the three curves. And start to make the loft. Now we can start to make our pattern. So we have two ways to make the pattern direct on the surface, or we can make like individual or spread sheet regarding to the U and V value for this surface. It will be more easy regarding to the normal points. We don't need to use the normals regarding to each point for the panels on the surface. We can use quickly on our spread rectangle and then reflect directly to the surface. So how we can do this? We can first need to get my U and V points regarding to this surface. So from here I will go to use the minimum and maximum value to create the rectangle. So from here I connect my surface. You will keep this deconstruct domain, we will use it later. So for now I will use this one and I start to create my rectangle regarding to domain. And connect to my X and Z. We can move this one a little bit in case of we need to see correctly what you want. So we can change the point of this plane. So let's say on the top, we can take it by, let's say -50. And create the point. Let's make it like 200. And we can move now my rectangle here. Now we will work on this rectangle. So directly I will use my lunchbox, diamond panel, connected, and then make the division, let's say 30. And then I will start scale to give me the shape of these surfaces for each panel. So I will use first area to get my centroid, the center points of each panel. And then I will start to create curve. The curve, it will be my way to select the pattern in the same way of the curve. So when I start to make my curve, and then let's select curve. And then I will start to select the close point regarding to the curve. So I will put my all center points for the panel regarding to the curve. So he create for me points regarding to the close distance from each point to this curve. For example, this point to this one, this point to that one, choose the shortest distance for each point. And the way of that one that I need to use it because I want to select the nearest panel around the curve to create my shape regarding to this curve using only the panels that more close to this one. So if I check the panel here, I can see all the distance related to all points. So I will list it from small to big. So if I back now to my panel, make it from the small to the big. So I need to the reverse because I want to the biggest number. And from here I will choose only the first biggest number. And then I will use this biggest number and divide it on 2 to just select the nearest panels. It will be just a number in my equation. So let's say multiply by 2. So now in this case, this is the half, now 30. Then I will use the call pattern. I need to use call pattern to remove all the panels unneeded smaller than this number, like the half of the biggest number. So I will choose smaller. So the first number, it will be the distance, and smaller than the result of the 30. And then I will connect to this list. So I can see now he have a pattern from the false and the true regarding to the distance related to the 30. Then I will use this call pattern for all the panels, all the center points for the panels to scale the panels that I need to give me the shape. So call pattern, first list it will be diamond, and I will use this call pattern, and then my centroid and use my call pattern. So now I create my two call pattern, and the reference now for the main call pattern, it will be the key from the big to small. So when I connect this one, I can see now he choose the all nearest pattern regarding to the line. And now let's start to scale all these panels regarding to this line. So I check first, I have now my pattern, I have now my center points. So when I start to scale, I need my geometry, I need my center points. Now it's all equal. Then we will start to put the factor, and the factor, it will be the indication regarding to the distance to give me the gradient scale regarding to the distance from each point. So first I will make also call regarding this time to the distance, and then when I check the panel, I have now my distance, but with huge scale. I need to scale it between 0 and 0.9, so I will remap the distance. So remap, and always when you use remap, we always quickly use bond to connect it to the source, and it will be the value, main value here, and the source from there, and the new target, it will be construct domain from 0.1 to 0.9. Even we can use the maximum, let's say and connect to the target, and then I will start to connect my factors. So I see here it start to give me the pattern, but we need to flip, so I will connect and flip way in the domain. So let's hide and see the last result here. So now I got my final result for the surfaces regarding to this one, we can also close this one, and like distance is very near, we can reduce in this case this one, let's say 90 to give me more space. And now I need to get the curves regarding to this surfaces. So from geometry, if I choose curve and connect, yeah, I can now get my curves in the panel. It will be all okay, and then I will make a connections between these surfaces and the main rectangle. So I can back to my rectangle, let's say relay, let's connect it here and take it. And in this case, I think if we use ruled surface, I have curve A, let's make sure this is flattened, and curve B. No, it's not connected in this way, so we can use boundary. So I will merge and flatten and connect. So yes, so each surface it's used in this way. So once make merge, make sure that I flatten to put all the list in one item to can read it as all edges, not read it as a two list. And I can extrude in the direction, let's say the very small extrusion. I can close this one now. Now let's back again my extrusion and geometry that I created here to my surface. I can do this by surface morph. So I will select my geometry and the reference, it should be bounding box. So I will choose bounding box and make sure when I connect this one, it will create bounding box for each surface here. So I need to make sure that it's union to create only one box. It will be my main reference. And then I will connect my surface that I created from the beginning. So I can use also here relay. And also I will use now my domain to create my U and V component, that I will use it here for this domain. And in W domain, it will be the same thickness that I use it here in the number slider. And make sure that everything now okay to connect. Once we connect and load it, I can see now here make all the reference regarding to U and V value back it here to our surface. And then once I finish my surface, so now I can bake. So now in Rhino, I already create my shape. So once I finalize, I can now use this pattern if I need it to put it also in Revit if I want to use this one as a SAT file. So let's save this one. And now I don't need this line, I can hide it. Now let's try to transfer this surface to the Revit. So from file I will select and export selected to be SAT file. So now I have here my SAT file. Let's go and open Revit. And let's start to new. Let's put it in mass. Make sure first I use the meter same as what I used in Rhino. And I start to open my Dynamo. In Dynamo I will use import SAT file and should be from file path. So I can get my SAT file and connect it here. And now very easy to load my surface. And to back my surface to the Revit, so I need to export it. So I will use Springs package from Spring package. Let's go Revit, and Revit I will go to Form, Geometry, and connect my geometry. So he will load to export my surface now to the Revit. So now once download, I have now my surface on the Revit that I can load it as a family and use it in my project according to the point or the coordination that I need it in my project. So thank you for watching, and don't forget to subscribe our channel in YouTube and follow us in Instagram, ar.arena design, and see you in the next videos.